Okay, now let us focus on power of a vehicle in motion. So here we are going to consider a vehicle being driven along a road by a forward force F applied by the engine working at a constant rate of P. So that's the power the engine is producing. So when it produces that power, that is going to be the forward pull that is going to be driving that vehicle. So remember that our power is given by work done over time taken. But work done is given by force times the distance over time taken is going to be T. So now, because this is the product, I can combine this and this, or this and this. So now, if I combine this and this, because I'm seeing distance and time, which is going to result into velocity. So this one is equaling to velocity, which I put in like that. So power in vehicle is going to be given by the forward pull, then times the velocity at which that car is moving. Okay, it's the attractive force offered by the engine. This force is given by that. In moving vehicles, non-gravitational resistance means frictional force. At maximum speed, acceleration is 0. Of course, maximum speed means that it's going to be a steady speed or uniform speed. So there's no change in velocity. That's why we say it's 0. Because we say acceleration is the rate of change of velocity. Because at maximum, it means that it's going to attain that velocity. So meaning there will be no change in velocity. So solving problems in the moving vehicles, draw a clear diagram, resolve perpendicular to the direction of motion, use power as attractive force times speed. If velocity is constant, the vehicle is not moving up. The vehicle is not accelerating. What's moving at a steady speed? Then resolve the force's power to the direction of motion. If velocity is not constant, then vehicle is accelerating. The vehicle can be moving, but when it's not accelerating, accelerating means that it's changing velocity. As simple as that. While down, if it is an acceleration, then find the resultant force acting and write down the equation of motions in direction of motion. Direction of motion means the direction of the acceleration, where the vehicle is going. Okay. Here, then let us see vehicles. These are the common cases we are finding. I'm going to give you then others you are going to see as we are doing the questions. Vehicle on a level ground moving with steady speed, it means that the acceleration is 0. So this is the level ground. So you see that now instead of using, because we are having a resistance here, the frictional force, that's why we are having it there. Then this is the force that's going to be pulling. Then this is what would have been our known. Then this is the weight. So resolving perpendicular to this plane, is that end is going to be down because there's no acceleration, meaning these forces are balancing and even these ones are going to be balancing as is there. Then our power is equal to F times the velocity. Then if we have acceleration A, it means that now in this direction there's no acceleration because the vehicle is not moving up, but it's moving horizontally. So meaning this and this are balancing, so they are equal. Now, the force that if the acceleration is this side, in this direction, it means that this is what is pushing the vehicle in that direction, then minus the resistance, it will be equal to the mass of the vehicle at times the acceleration. Still, our power is equal to this. Now, if R is greater than F, then A is in opposite direction. It means that it will be in this direction, because if this one is greater than this, meaning it's going to be pulling it in this direction. So that's when we'll see that will be having some negative accelerations if you constant a direction opposite to what is in actual sense. So note that vehicles on a slope of inclination theta degrees. Let us start when there is no acceleration. The same idea. We resolve this weight through this and this. Then perpendicular to the plane, this will be equal to that. Then in that direction of the force, this is going to be this, then minus this, and then minus this. But because there's no acceleration, it means that this is equal to these two. So that's what we have there. As is power, we already stated the power as the first time was the velocity. Then in the case of acceleration, let us say that we are going to consider acceleration in that direction. It means that now we are going to be having a mass times acceleration. So we shall get now this force minus this, then minus this equaling to MA. Then power is equal to force times velocity. If you find that this is greater than, if you find that this is greater than this, that means that the force is going to be, the acceleration is going to be down the slope. So we are going to see now examples in the next lesson. Please don't forget to subscribe to the channel. See you there.